Hi everyone, welcome to this new lecture of fluid mechanics. In this lecture, we'll discuss a problem on Bernoulli's equation. In our last lecture, we have discussed the theory part of this Bernoulli's equation, and let's solve one problem on this. So the question is given, the water is flowing through a pipe having diameter of 20 centimeter and 10 centimeter at section 1 and section 2 respectively. The rate of flow through a pipe is given 35 liter per second. Okay, and the section 1 is 6 meter above the datum line and section 2 is 4 meter above the datum line. If the pressure at section 1 is 39.24 Newton per centimeter square, find the intensity of pressure at the section 2. The question is very simple. Okay, what we need to do, we need to first identify that how the flow of water is having. Okay, so let's see, two different sections are there. Okay, and two different sections. One side, if you see, the diameter is given 20 centimeter of the pipe, another side is 10 centimeter. That means it is an divergent type is there. Okay, no, convergent type. That means bigger, it is larger here and it is smaller here. That means convergent type pipe is there. Next is section 1, section 2. Section 1 20 centimeter, section 2 10 centimeter. And section 1 is 6 meter above the datum line. Let's first draw one datum line here. So this is the support datum line, XX line is there, and the pipe is suppose from here with the height of with the height of some 5 meter or 6 meter is given. So that is here 6 meter suppose. So this is 6 meter height is there. Okay, and second datum line, second section datum line, that height is given, this is 4 meter. If you see this line, it should be like this. Okay, so the pipe should be, it will be moved like this. And now here in this pipe, if you see the diameter of the pipe here, it should be suppose this is the diameter of the pipe, okay, which is having 20 centimeter, and here the pipe diameter is 10 centimeter. So now you just join this pipe. I hope you understand. So this is the section 1. You can see this is section 1 and this is section 2. Okay, so now the flow is flowing in this way. Okay, this is height of 6 meter, this is the height of 4 meter, and everything is there. Now this is the diameter of this inlet, diameter of this outlet, all the things given. Now what I'll do, I'll just write the data given first immediately. So section 1, let me write at section 1, you can write the value of this diameter D1 equal to 20 centimeter, that means 0.2 meter, and area equal to, based on this we can calculate pi by 4 d1 square. We'll get some value here. Okay, that I'll write later. Now anything pressure is given also here at this inlet. If you see the pressure section at 1, this is section 1 and this is section 2. So at this section 1 the pressure value is given 39.24. so P1 we can write 39.24 Newton per centimeter square. Now this one we have already converted into meter, so this also let convert into meter. So that will be 39.24 into 10 to the power 4 Newton per meter square. So these are the things given in the section 1. Similarly at section 2 we can write section 2 diameter is given D2, and here one more thing is given Z1, the height of this from this datum line. So that is, we need to write here Z1 equal to 6 meter. Similarly D2 diameter is 10 centimeter, so that also we can write 0.1 meter, and we can also calculate A2. Similarly pi by 4 D2 square, we'll get some value here that I'll write later. Okay, and Z2, the distance from the datum line from here to here, that is 4 meter is given, and here we need to calculate the value of pressure at this second point. These are the things we need to identify. And one more thing is given, the rate of flow, the liquid which is flowing through this pipe, that is given Q. So Q equal to 35 liter per second given. 35 liter per second is given. So this one we can also convert into meter cube per second. So that will be by divided by 1000, we will get 0.035 meter cube per second. Okay. Now what I'll do, I'll just find out, because see, the velocity need to be calculated, because as we know, we have seen the Bernoulli's equation, if you remember. So let me remind you the Bernoulli's equation, that was P by rho g. I have given P1 because I'm writing for section 1, and similarly B1 square by 2g plus Z1 equal to, this is one side, one section. Similarly other section you can write P2 by rho g. Now here rho 1 and rho 2 will come, but here same liquid, that's why I'm writing rho only. And here this is V2 square by 2g, and this is plus Z2. This is the equation. Now here if you see, P1 is there, rho is known, g is known, and V1 not given, Z1 given, P2 need to be calculated, Z2 given, rho g value is known, g value known. So how many unknowns are there? B1 unknown, V2 unknown, P2 unknown. So now what I'll do, I'll just quickly find out the V1 and V2. And after that we can find out in this whole equation only one unknown will be there, that is P2. So V1 we can write, we know that one thing, in the continuity equation we have seen Q equal to, there is no Q1, Q equal to A1 V1 equal to A2 V2. So here if I write only this equation for find out the Q, so I can write V1 equal to Q by A1, correct. So Q equal to 0.035, and here A1 equal to pi by 4 D1 square, correct. So from that we'll get the value of this. So what I'll do, I'll just write this quickly. Let's calculate this, take this calculator, and the value of A1 here, if you write pi into D2 square, 0.2 into 0.2 into 3.14 divided by 4, 0.0314. So 0.0314. Now if you see, this is 0.035, okay, and this is 0.031. So very it is not nearly same, near about. So what we can do, just to again 0.035 divided by 0.0314, I hope, yeah, equal to 1.11. So your velocity V1, we are getting 1.11, this is meter per second, correct. Now similarly Q2 V2 also we can identify. Similarly we can write V2 equal to, I can write Q by A2 based on the area. So Q already there, 0.035 divided by A2. A2 is again pi by 4 D2 square. So similarly we can again just calculate it. So what is the value of, 0.1 into 0.1 into 3.14 divided by 4, 0.00785. So finally we'll get 0.007, this one 0.00785, and if you divide this again, we can calculate this, 0.035 divided by 0.00785, 4.45 meter per second. So this is our velocity V2. Now in this equation, if you see, all this value we got, V1 we got, then this is V2 equal to 4.456 meter per second, suppose, okay. And now remaining things values are given, so just put all this value in this equation, we'll get this value of P2 by rho g, okay. So So let's take this to next page. So let's write here P1 value is, let's check it, 39.24. So let me write 39.24 into 10 to the power 4. This is P1 by rho g. The water is there, so I can directly take 9,000 rho g 9.81 plus V1 square. V1 we got 1.1, I think, square into divided by 2g, 2 into 9.81 plus Z1 6, the height of that, and again P2 we need to calculate P2, so that let it as usual 1000 into 9.81, and this is V2 square. So V2 is, we got 4.46 or something, 4.45 something we got. This is square and divided by b square by 2g, 2 again 2 into 9.81 plus Z2 is 4 meter. So these are the data given to us, correct? Now what I'll do quickly, I just find out what the value will be there. Here if you see, if I take this is 10, so it will be 10,000, correct? So 10,000 with 10 to the 4, so this is going to be cancelled. Both will be going to cancel, and this will be some value will be there near about 40 will be there, suppose. I hope you understand. 10 to the 4 is there. So here 30 will be cancelled. So 10 by 9.81. So we'll get some value, point something will get it. So just multiply in this, we'll get 1 point something into 39.24, that will be 40 near about. Okay, I just taken the approximate value, and this one 1.1 square. So this will be, 1.1 into 1.1 divided by this is 19.62, so that is 0.061. So I can write 0.06, okay, plus 6. Similarly here we'll get P2 by some value 9810 plus this value also similarly will get some value 4 point, here what I'll do, 4.45 into 4.45 and divided by again 19.62, 1.009. So we'll get 1.01 suppose, and here it is 4. Now if we take only P2 one side and remaining thing other side, if you get it, so what I'll do, P2 by 98106, no 6, only 4810, we'll get the value here. How much is there? 40 plus 6, so 46.06, and this is 146.06, and this one I have taken in this side, remaining side, that will be minus 4 plus 1.0, 5.01. So we'll get near about 41.01, some value 5 will get it. Okay, and now next is we need to again find out the P2 value. So P2 will be 41.05 into 9810, and finally we'll get the value of this P2. So again we'll just multiply this 9810 into 41.05, suppose 4,02,000 something, 402,700 something we are getting, correct? And if you see this value, now we can write 10 to the power 4, this is Newton per centimeter square. Suppose we are going to get, no, this is Newton per meter square we are getting, because everything is meter is there. Now say same thing if I want to write in the terms of Newton per centimeter square, just to divide this 10 to the 4, then what will get 40.27, this one 40.27 Newton per centimeter square. So this is the pressure at the second, second section, this one at this section. So the question is very simple given, only we need to identify the value of pressure or velocity, whatever the things asked in the question. Based on this, first of all you draw the diagram based on the question. First of all you draw the diagram, and indicate the location of this height and indicate the section, section 1, section 2, and what is the pressure is given, what is the velocity is given. Suppose V1 given here, and here it is V2 not given. Then I will to identify the V2. But in this question, V2 also not given, V1 also not given. And here pressure P1 given, but here pressure P2 not given. Okay, so V1, V2 we can easily identify from the flow rate, that is Q, because we know that Q equal to A1 V1 and A2 V2. So like that we can, and this is the Bernoulli's equation that need to be remembered, and we can easily solve the problem. So I hope you understand the question. If you are having any kind of query regarding this, you can give a comment on the comment box. Thank you all.